Umar, can you kindly share your camera? Okay, good. So thank you, Umar. Kindly be there for some time. Umar has been with Variance with us from the past 3 years, and he is an expert in many technologies that is related to AI. And let me just probably list it. It is convenient that way. Okay, so Ruby on Rails and Python are some of his specialities. So Umar, would you like to give a quick intro of yourself, please?
Hello all, how are you? My name is Umar, and I'm working as a Unity AI developer and Python AI developer, ML developer in Variance Infotech Private Limited since 3 years. Hope you are all safe in the pandemic. And shall we start the seminar now?
Yeah, we can. So I'm just putting my camera off just so that we can save some bandwidth.
Yes, okay.
Okay, yeah. So now, when we say computer vision, what does it come to our mind? And what are the applications of computer vision is what we will Umar will tell us now. So quickly, a word about computer vision. So we must have all wondered about what's called self-driving cars, which are the recent trend and which have become very popular these days. We also have been uh, amused about so many other things of um, AI and the applications where you get to automotive industry is one of the very famous, very beneficiaries, and how to detect diseases in agriculture or in healthcare industry, and how do you probably uh, use it in criminal cases to solve them earlier, and what are the how do we have a tour of the house much before we plan and build it. These are a few uses of computer vision and the related artificial intelligence technology. So you can probably get to answer. You can email us your questions after the seminar whenever you have any doubt. So currently Umar is going to show us and tell us about show us the application which we have developed using AI, and he's going to tell us more about computer vision also. So Umar, it is over to you. Are you able to share the screen? Can you confirm
No,
your
I'm not able to
presentation?
share the screen right now.
Okay, let me make you the presenter so that you can share your screen. Okay, now you're the presenter, Umar. Maybe you can share the screen now.
Yes, wait a minute.
Yeah,
Okay,
we are able
so
to see your screen.
okay, so uh, we are gonna start the presentation right now. We are starting the topic computer vision introduction and use cases. First of all, here is the introduction. So what comes in our mind when we talk about computer vision? That computer vision is a sub branch of machine learning, which which is used to uh, give the visual perspective to computers and the mobile phones. We are living in the era of machine learning right now. So and the computer vision is currently having the big impact on the market. Right now, computer vision has, as of now in the 2020, 14.1 billion dollar market share in the current era of the 2020 as of the pandemic, and it is expected that it will grow to 19.1 billion dollar till 2027. So it has a huge impact in the market. So what is the machine learning part of the computer visions? So computer vision is basically a technology which gives visual system to the computers and mobile phones, which a human can do, like recognize the objects like a car or a human person, or maybe a cat or a dog, etc. So machine learning computer vision is just a perspective, visual perspective, to the is giving the visual perspective to the computers and mobile phones. So computer vision is an indisciplinary scientific field that deals how computers can gain a high level understanding of digital images or videos. From the perspective of engineering, it seeks to understand and automate tasks that human visual system can do. So
Interdisciplinary, you mean, Umar, correct?
yes,
Interdisciplinary, yeah.
yes. So what computer vision does is it simply gives the visual system that it can recognize the objects from the digital images and videos, and then react according to it. Like if there is a car or a human person, so if there is a car, so it can recognize which company's car is it, or etc., like that. And there are major 5 techniques in computer vision which are described here. First is the image classification, second is the object detection, third is object tracking, fourth is the semantic segmentation, and fifth is the instance segmentation. I will explain each of them turn by turn. Sorry, please wait a minute. Okay, so we are now heading towards image classification. So what is the image classification? So image classification is a technique through which we can input the image in the computer, and it will recognize what the object is. Like, is it a human, or is it a cat or a dog or a car maybe, or vehicle or something. So how does the image classification works? So image classification takes lots of images of a category. Like if we need to if we need to detect a vehicle like car, so we will take a lot of images of the vehicles from the different angles and different perspectives, and we will label it with the tag car. So, and we will create a data set like that. And what we will do is, next we will train a classifier with that data set, and we will train a machine learning computer vision model out of it for the image classification. And then if we pass the image which is not even in the training set we have given, it will compare the input image with all the images which we have labeled and trained the model with, and give the prediction if it is the car or not. But the limitation of image classification is that it only detects and it only gets trained on the single object. We can't train it on the multiple object. In only one image we can only label only a one object, not multiple objects. Here is the example in the next slide for the image classification. Like, here is the here is the image of a person. So the image classification output will be like this. If we input the original image, and it will detect if the person is there or not, and it will label it like this. So, and the next is object detection. So object detection improves the limitation of image classification, and what it does, that we can label multiple objects in the images and train the data set out of it, and we can create the model from that only. So what do we need to do is that we need to create the bounding boxes around the objects, and we can take multiple images, and we can annotate multiple objects in all the images, and we can train the model out of that. So if then we can and so if then we evaluate the result and predict the images, it can detect multiple objects and multiple vehicles or humans in that image. classification, it can detect multiple objects. As I said earlier, here is the example. Like here you can see that like here you can see that in this original image, here is the one person, here is the another person, here is the car, and here are the trees. So if we create the data set, like creating with the bounding boxes and annotations for the car, trees and humans in the same model, so the output image will be like this. So we can get the vehicle detection also from the image, trees detection also, and the person's detection also. Unlike image classification, it detects multiple objects, so it is more efficient than image classification. And now we will head to the third one, which is object tracking. So what is object tracking? Object tracking is an enhanced version of object detection, we can say. Like what it does, it works in videos or in the real time feed in the live camera. So this object detection technology or method works on the images and videos, but it cannot track the motion of the person very efficiently. So what does object tracking do? It gets it gets the input from the video or the live camera feed, and it divides it into the little frames, smaller frames, and per frame it passes the image frame into the model which we have trained earlier, and then it gives the output, and it is very efficient and fast than object detection. So and for the data set creation, it is just like object detection. We have to create annotation and bounding boxes around the objects in the images, like object detection only. So here I'm gonna play the video for the object tracking for the example. As you can all see that I have taken the clip from the famous Bond movie, James Bond movie Skyfall, and you can see the detection, like the vehicles are moving and the people are moving, and so the detection is going on in the video, and it is tracking the objects where it is, where the car is going, and where the person is going.
Yeah, we are able to see Umar. So can we do this for any video? I mean, any video is running and we can apply this, and we can try to capture all the elements.
Yes, we can run it. Yes, we can run it in any video, and also the live feed we can do it.
Okay.
Okay, so we will now move on to the next one. Please wait a minute. Okay, so here now we are at the semantic segmentation. So what is the semantic segmentation? That it is different than all the three algorithms, like image classification and object detection and object tracking. What does semantic segmentation do? That it labels each and every pixel in the image. It labels each and every pixel in the image, where the person is located, or a car is located, or a flower is located, or a piece of furniture is located, or where is the sky, etc. in the image. So what does it do? We have lots of pixels in the image based on the resolution and quality of the image. So it detects and labels each and every pixel location, where the person is located or the car is located, etc. in the image, and it labels all the pixels, and it gives us the classification by detecting the lines or the edges of the object, and it gives us the better perspective of the output and prediction. It is better than object detection and tracking and all. It does not create the bounding boxes, but it takes the exact shape of the object. Here is the example. Like as you can see in the image, like in the previous image in the object detection, what we have saw that it creates the bounding boxes in the output. So what does the semantic segmentation do? It detects edges all around in the image in the which we are providing the original image. And what does it do? That it detects the edges from the every object, like in the human body, or maybe the street lights, or maybe the vehicles, or trees, or buildings, roads and footpaths, etc. and and it classifies each and every pixel in the image. So what does it do? That it detects the exact shape based on the pixel, and it classifies the objects in their category. Like there are two humans in this image, so it has colored it red. And so there are two vehicles in the image, so here it is blue and here it is blue. As you can see, here is also the car and here is also the car. And the buildings are given the brown color, sky is given the white color, and the poles are given the pink color, and footpath is given the teal color, roads are grays. So it can detect each and every object, and based on the edges of the object, it classifies what pixel should be labeled as road, what should be labeled as human, what should be labeled as vehicle, what should be labeled as building and trees, etc. So the efficiency is there, but there is one limitation, that we cannot count how many objects are there in the semantic segmentation, because we have one category for human, one category for car. So what does it do? That if it detects the human, so it will there are here two humans in this image, so it has done the red color in both of the humans. So we cannot count that how many humans are there. It is detecting it is detecting where the pixelized locations are there in the image for the human and the car, but we can't count how many humans or cars are there, because it defines with it with the same class and same color, so we cannot differentiate. So to improve this so to overcome this issue, overcome this limitation, we have another method named instance segmentation. So what does instance segmentation do? Instance segmentation labels each and every pixel of the image. uh, what does the semantic segmentation actually do? Semantic segmentation just check for where are the pixels which have the person or human or vehicle, etc. And it all, and suppose for the one category, like for the human category, where it detects the human, it will only define the human, only label, it will label the pixel only for the human category. But what does the instance segmentation do? Instance segmentation will label each and every pixels and each and every object's pixels into different unique ID and different unique label. So what does it do? That it will it will give output like this. I have taken only the three classes in this image. So what does it will do? That if it detects one human, so it will give this object or this human only one label, that's person one or human one, and the other person human two, or the person two, and the car one tree two, etc. So what does it will do? That it will differentiate the objects based on the edges, and also give the different labels and different unique IDs, so we can count each and every object in the image. Like there are, in this image we can differentiate that there are two humans and two trees and two cars, etc. this is the difference between the semantic segmentation and instance segmentation. And now we can head over to and now we can head over to tools and technologies. So there are lots of tools and technologies are available for achieving this all the methods and state of the art computer vision predictions and outcomes. Here I have mentioned some popular ones like the YOLO, TensorFlow, Keras, OpenCV, and PyTorch and Caffe. So I am gonna explain two three from this. So what does YOLO do? That YOLO is basically created by computer vision scientist named Joseph Redman. He created YOLO for the he created YOLO for improving the object detection and object tracking methods. Like in the previous times, image classification was only there. So what image classification needs is lots of image for only the single category, and it can only detect the single entity in the or object in the image. So he invented YOLO to overcome this limitation and improve the detection, performance, and speed. So YOLO, what does YOLO do? That it takes lots of images, like maybe hundreds or 500s or 1,000 images, and we have to annotate it and each and every object, and we have to give the class, and we can train the model out of that data set. And after the training we can evaluate the performance after giving some of the test images and running the inference test on this and on that. And we can then give the any and then we can give any image, so we can get the output like this one, this object tracking example. It is based on YOLO only.
YOLO stands for something, Umar. Can you please help us?
Yes, YOLO stands for you only live once. Here, the creator of the YOLO framework has named it YOLO, you only live once.
Okay.
And
So,
next is stands. Yes,
sorry,
continue.
I was just going to ask you, for the benefit of all the attendees, are you going to show us installation and something of any of these today, or you are going to only explain the features?
No, as we have mentioned earlier that we are gonna give the basic info and just intro for the computer vision. In this
Okay.
webinar, we will only discuss the theories. For the practicals installation and
Okay.
further technical details about each and every the technique, like we have discussed for the image classification, object detection, and object tracking, semantic segmentation, instance segmentation. We are gonna set the another webinar for the detailed discussion of, for the all the topics which we are
Okay.
giving the intro right now, and we will give the practical demo over in the next seminar also.
Okay. No problem. No problem. Okay. Please carry on, Umar. Yeah. TensorFlow.
O- Okay. So what is the TensorFlow? So TensorFlow is an open source. So TensorFlow is an open source machine learning library developed by Google for a better detection of objects. It is just like YOLO, but Google has developed it, and Google has made it open source, so anyone can take the source and check and modify for the better performance and all. So TensorFlow has many features like image classification, object detection, semantic segmentation, instance segmentation, and also it has new features which Google has developed and added in TensorFlow, like natural language processing. We can create assistant like just like Google Assistant. With this, it gives machine learning models for NLP like BERT system. So what does the BERT system model do? that it is based and trained on the text question answers. So what does it do? That if we are giving anything in the chatbot, like it is trained on the BERT, so what is it does that if we give any question like hello, how are you, so it will tell us that I am fine, how are you. And if we ask any questions like related like sales or maybe inquiry, that what is the price of the product and all, so it can act accordingly based on BERT model based on the TensorFlow. There are lots of others also. TensorFlow gives other detections also, like speech recognition, voice recognition. There are lots of features which we are gonna also discuss over in the next webinar. And Keras is also one API for the TensorFlow. It extends the capabilities of TensorFlow only. OpenCV is developed by Intel, and it is also open source. It has many features like threshold and edge detect. It has many features like edge detection, half lines detection, with which we can detect the lines. Edge detector, which detects the objects, lines and edges, and gives us the output accordingly. We can set the threshold for checking the image quality, etc. There are lots of features in the OpenCV. PyTorch is developed by Stanford. It is just like YOLO and TensorFlow. It also gives the natural language processing features just like YOLO and TensorFlow. Caffe is also a deep learning framework. What it does that it is also used in object detection and image classification and all. So these are all the popular ones which are used in the market right now.
Okay, sounds good. So are there more or only these?
Yes, there are many more, but
Okay,
we can't include all of them.
these are
So I have
significant.
just yes. So I have mentioned the best ones and the most popular
Oh,
ones, which
okay,
which developers around the world prefer to use.
okay, good. Okay,
Okay. So now we are heading to the use cases of computer vision. These are 7 use cases, but these are not the list. There are many use cases, and there are lots of developers and scientists, computer vision scientists, which are creating innovation through computer vision. So we cannot include all, but these are the most famous ones which are being used right now. So first is the object counting. Like I explained previously, we can do object counting from the image or video, and we can also detect emotions of the person who is sad or angry or anxious or happy, etc., with the use of webcam in the real time also. Motion tracking, so we can track motion also, like I have shown you in the object tracking example, that we can track where the person is going or where the car is going. So earlier you have mentioned Sangeeta, that we can build anti-theft softwares also and applications also with the help of machine
yes.
learning. So we can use motion tracking to detect theft
Mm-hmm.
also. Motion tracking, we can use motion tracking to detect theft also. And there
Okay,
are self-driving vehicles, like you have earlierly mentioned that there are many self-driving cars available right now. So Google has also launched Waymo branch, is its sub branch of the Google, which works in the which works in self-driving vehicles, and they have launched it in the Phoenix City in the Arizona, where they have
okay,
successfully implemented it.
okay,
And now they are planning to move to London for their next phase. Google has efficiently developed, and it's right now working in the US, in the Arizona city.
okay. That's good. Okay,
Okay, and Tesla is also making self-driving cars, and lots of other companies also provide self-learning car kits, so we can add it in our car only and embed in our car only and make our ordinary car also the self-learning self-driving cars.
Okay,
There are
that's
lots
good.
of companies which are giving this. And fifth is the facial recognition. So what is the facial recognition? We all know, right? We have facial recognition systems in our mobile phones right now. It is nothing but just a computer vision technology and a technique which detects your face landmarks. We have
Yeah,
68 landmarks in our face, which detects the edges of our face and eyes and nose, chin, etc. So facial recognition is also the part of computer vision. We can
yeah,
also detect diseases like skin diseases or skin rashes or skin cancer. We can also detect the diseases.
mm,
And right now in the current period of pandemic, as we are all knowing that we are going through the pandemic time. So the detection of COVID-19 is also possible with the computer vision, and many of the institutes are researching further that
mm,
based on the x-rays of the chest, they are detecting how much is the COVID, how much the infected person is, etc. Cancer
okay,
detection is also possible based on how much defected are the cells in the human body, etc. So doctors are also automating their tasks and to give the better and fast results and efficient results to provide better cure to the patients. So it is being used in that field also, in the medical field. And last I have mentioned here is the traffic analysis. So traffic analysis we can also do that, like like if you want to know that how many vehicles are there in the current uh, road, like if there is a lot of traffic jams occurring, or maybe the person who is going wrong side in the way, so we can also analyze the traffic and detect who is going wrong side, or the people are crossing the line, or breaking the traffic rule, etc., or there or is there overcoming traffic in the area, so we can manage it and counting the vehicles, that how much of the traffic is there, etc. So we can do the traffic analysis also. And the self-driving cars also, the traffic analysis is important, right? Like the self-driving car needs to detect the vehicles, or maybe from the crossroads, like humans are crossing or maybe animals are crossing the roads. So it also needs to analyze the traffic, that from which side the vehicle is coming, or any person or maybe the animal is crossing roads or not. So traffic analysis is also being used in the self-driving cars also, to make the car efficient in the self-driving and to avoid any accidents, etc. So I will move on to the next one. Here is our app. I have earlier mentioned that we can count objects in the image or maybe in the video. So here we have developed a app called Jet Counter, which counts the objects from the image. We can take all the picture from our camera, or we can take the photo and pick the photo from the gallery, and we can count the image, and we can count the objects in the image, just like Sangeeta told you all earlierly. So I am just gonna play a demo of the Jet Counter app which we have developed. And what does it do? And what does it do? That we have developed different machine learning models for this application, so users don't have to download all the objects, all the objects, templates or models. User can only download which of the template or model he or she needs to count, and so now so they can download only that object template. So here is the downloading process, which is shown here. as as you can see in the video, as you can see in the video, that I have downloaded the model of the walnuts. As you can see in the video, that I have downloaded the model of walnuts here, and I have taken a picture from the camera only of the mobile phone, and after taking the picture, you have to just tick mark the right check, and it will give you the count in no time. So it is very efficient, and it is just the example of object detection from the images, as I have talked earlier.
Okay, Umar, is this available in Google Store already?
Yes, you can download it in the Google's Play Store. We have already uploaded it.
Okay, so are we going to charge the user for the use of this?
No, right now we have not uh, placed any charge. The app is free to use right now.
Okay, so I understand I can count, dry fruits. I mean, it is an example, and of course, say fruits on a tree, I can count. If I go to supermarket, I can count how many things are placed on the shelf, and if I sit and if I try to uh, count the number of cars that is passing any toll or something, I can do that. And maybe I can
Yes.
also measure the speed of any moving vehicle if I apply the right use. So this is all in all a very useful tool, I must say. So good, congratulations and good job, Umar, on this. And we
Thank
will
you.
probably, so if you're done, can we ask for questions on chat? We have 4 more minutes. We will wait for users to ask any questions if they have, and let us see if we're able to answer them. Otherwise, they can always email us their doubts or clarifications, and we can help them later.
Yes, sure, definitely.
Okay, so attendees, you can probably put your questions in the questions pane, or you can in the chat window you can type. We have 4 more minutes. Okay, in the meantime, maybe Umar, you can tell us how much time did you take to develop this tool, this app?
In developing this app, currently we have included the 14 categories, some of which are the non-living objects like logs and vehicles and pipes, etc. So we have added the face detection also, and some of the we have included the food items like almonds, cashews, and walnuts. So it took us 3 to 4 months approximately to add
Okay.
the 14 categories in that.
Okay, so you mean to say
And
the
right now,
development time is based on categories, correct? I mean, how
yes.
much features we give, how much categories we give our development time. Okay, that's good. So we can go on improving this over a period of time, is it not?
Yes, we are already working to add more categories, and also also improving the counts in also improving the results of the counts in the application also in
Okay.
the current models.
Well, looks like you have done a good job, Umar. That is why they don't have any questions.
Okay, so
So if there are no questions, I have anyway given them the email ID and they can get back to us whenever they want on any clarifications regarding jet counter or regarding computer vision as a technology.